Hey everyone, and welcome to the fourth lesson in our geometry unit. And today we're going to talk about the volume of three-dimensional figures. And given basically what we already know about polygons and area, this should be relatively easy. There are just a few rules that we need to follow. Um, yeah, so let's kind of hop right in. And the primary distinction that kind of comes up with volume first is that um, oftentimes we're either dealing with a prism or a pyramid. And to tell the difference between those two, um, here I'll just kind of show us what a prism would look like. Okay, so a prism, and if I draw basically the back end of this prism, is a three-dimensional figure, and the important piece basically here is that there are two opposite parallel bases, and we see the exact same shape kind of throughout. So that is what gives us a prism. So to find the area of the, or sorry, to find the volume of a prism, we end up saying that, okay, the volume of a prism is the base times the height. And the important part about this base is that really this is the area of one of the bases. So this is a super generic formula, but the reason why it's kind of so broad is that it can be used if the base of your prism is a hexagon, a square, a triangle, a trapezoid, anything like that. So here, again, we said that our bases on this particular shape are these triangles. So I would figure out the base or the area of that triangle, and then I will need to be given the height of this object. And the height of a prism is the distance between your bases. Okay, so there was a lot of success and comfortability finding area. And the only difference here, there's going to be some identifying, okay, what is my base of this particular prism? But the only difference really is that we're going to be multiplying it by the height in order to figure out the actual complete volume of that. This also applies, and shouldn't take too much to kind of convince you, but this also applies to cylinders. Okay, so a cylinder is a prism by basically the definition that we've outlined, because it has two bases that are opposite one another and parallel. So finding the volume of a cylinder is basically the exact same thing. We won't even really talk about it from a separate standpoint. It would just be figuring out the area of the base or the area of one of those circles and then multiplying it by the height of the cylinder. Okay? Pyramids are probably, what we're expecting. So we can have, we'll just create kind of a square-based pyramid right here. And for the volume of a pyramid, the only difference, I'm still going to have this base times height, where I'm using a capital B to represent area of base, and H is still the height of my pyramid. The difference here is that we actually have this correction of 1/3. So, it's kind of an interesting, and there's a few different videos on showing the calculation of where that 1/3 comes from. But we end up seeing that if I took this area down here, so this is the area of the base of my pyramid, and generally easier to identify the base of a pyramid, and I multiply it by the height, which is going to be the distance basically from here to the top. So this would be my height. I end up over calculating by a factor of 3 because there's a bunch of missing space within that volume. And when I divide that by 3, I basically fix this to the point where instead of finding the volume of a prism, I'm now finding the volume of that pyramid. So that is kind of an important distinction there. So these same rules apply. Here we have this is the height from base to the tip of the pyramid. And then we also still find that this is the area of the base. So in this case, the area of the base is kind of a nice convenient square, but you'll often be dealing with cases where the base is something different. So that could be a hexagon, could be a trapezoid, anything along those lines. So we need to be prepared for that. And that also kind of highlights the fact that if I have to figure out the volume of a cone, this exact same rule applies, where I'm just going to be doing the area of the base, which is just going to be a circle, times the height, and then times 1/3. Okay, so all pyramids, including cones, we're going to call those pyramids really, are 1/3 area of the base times the height. The only two kind of distinctions that we need to make, so cone, we don't need to make that distinction, it's just see above, is our sphere. That's kind of a complex volume that we still need to kind of encounter. And this is a situation where the volume equation essentially stems from calculus, but we can apply it here with relative ease. So if I have a sphere with radius r, then the volume of that shape is 4/3 times pi times the radius cubed. Okay. And again, derivation of that kind of lies in calculus, so we're just going to be applying it here. So, we should expect that if I told you the volume of a sphere, that you could come up with the radius. If I told you the radius, you should be able to come up with the volume. Even some tricky questions here are, if I told you the volume of a sphere, we should be able to get all the way back to surface area. So those are some pretty good questions. We have a collection of problems, which basically I've said the minimum expectation is to be completing this page here. So that's 1, 2, 3, 4, 5, 6 problems. Down here we have some complex figures. So I'm noticing a rectangular prism with a cylinder on top. And then over here, I'm noticing a cube or a square prism with a cone taken out of it, or a circular pyramid. So just kind of make note of that. And then also, if this is something that you're finding success with, I highly encourage you to kind of take a look at some of these challenge questions, because these are really kind of push your thinking a little bit. Yeah, and I think you'd benefit from that challenge. All right, folks, thanks very much, and I'll